In 1993, a single man lay motionless in the dirt for 4 days. No food. No movement. Just a heartbeat and a rifle. When he finally pulled the trigger, a warlord's lieutenant dropped from 800 meters. No one saw the shooter. No one heard the shot. He crawled away like he was never there. The ghillie suit sniper system is not a weapon. It is the art of becoming invisible. For over a century, this technology has turned ordinary soldiers into phantoms. From the trenches of World War I to the rooftops of Fallujah, the ghillie suit has rewritten the rules of combat. Today, we trace every mission that proved one truth. The deadliest weapon on the battlefield is the one you never see coming. During the Winter War of 1939, Finland faced an overwhelming Soviet invasion. The Red Army poured across the border with over 600,000 troops. Finland had a fraction of that force. But Finland had something the Soviets could not counter: the forests, and the men who vanished into them. Zumo He-ha was a farmer turned soldier from the Finnish countryside. He dressed in white camouflage over layered burlap and natural vegetation. His ghillie technique predated the modern system but followed the same principle: break the human silhouette, merge with the terrain, become nothing. He-ha operated in temperatures dropping to -40 degrees. He packed snow into his mouth to hide the vapor of his breath. He positioned himself in snowbanks with only his rifle barrel exposed. Soviet patrols walked within meters of him. They never saw him. Over the course of roughly 100 days, He-ha recorded over 500 confirmed kills. He used a Finnish M2830 rifle with iron sights. No scope. The scope would glint in the sunlight. The scope would raise his head position by centimeters. Those centimeters meant detection. Detection meant death. The Soviets sent counter-sniper teams to find him. They failed. They called in artillery strikes on suspected positions. He relocated. They sent entire platoons to sweep sectors. He had already moved to a new hide. On March 6, 1940, an explosive bullet struck He-ha in the jaw. He survived, but the war ended 11 days later. His record remains the highest confirmed sniper kill count in any war. The ghillie principle made it possible. Visibility was his greatest weapon. But the ghillie system was about to evolve from improvised camouflage into a precision military technology. In the jungles of Vietnam, the United States Marine Corps established the first formal scout sniper program. The Marines needed a way to project lethal force deep behind enemy lines without detection. The answer was a revolution in wearable concealment. Carlos Hathcock was a Marine sergeant stationed in Da Nang in 1966. He became the architect of modern ghillie suit doctrine. Hathcock did not invent the ghillie suit. He perfected its battlefield application. His most legendary mission required him to crawl over 1,500 meters across an open field to reach a North Vietnamese army general. The crawl took 4 days and 3 nights. He moved inches at a time. The ghillie suit he wore was hand-built. Strips of burlap and jute fiber were tied into a mesh netting draped over his body. Local vegetation was woven into the fabric every few hours as the terrain changed. An enemy patrol walked directly over his position at one point during the crawl. A soldier's boot landed centimeters from his hand. Hathcock did not move, did not breathe. The patrol continued. He reached his firing position on day 4. 1 shot. The general dropped at approximately 700 yards. Hathcock reversed the crawl. Another 4 days to extract. No one detected his presence on either leg. This mission established 3 principles that define ghillie suit operations to this day. Patience is a weapon. Stillness defeats technology. The suit is only as effective as the discipline of the person inside it. The ghillie suit had proven itself in jungle warfare, but the next theater would test it in a completely different environment. The modern military ghillie suit system consists of 5 integrated components. Base layer of durable ripstop fabric forms the foundation. Over this, a mesh netting panel allows the attachment of natural and synthetic garnish materials. The face veil breaks the outline of the human head. Padded elbow and knee sections enable extended low-crawl movement. The rifle wrap applies the same concealment principles to the weapon itself, eliminating its distinct linear silhouette. During the Gulf War of 1991, coalition snipers deployed ghillie systems adapted for desert terrain. The standard woodland ghillie was useless in open sand. A new variant emerged. Desert tan burlap replaced green. Synthetic fibers mimicked dried scrubgrass. Lightweight mesh reduced heat buildup in temperatures exceeding 120 degrees Fahrenheit. Staff Sergeant Jim Gilliland's team operated in advance of coalition armored columns. Their mission was to identify and eliminate Iraqi observation posts before they could report troop movements. One team of 2 snipers in Desert Ghillies neutralized an entire chain of forward observers across a 12-kilometer front. They crawled into position before dawn. By the time the sun rose, they were indistinguishable from the desert floor. Iraqi sentries scanned their sectors through binoculars. They saw sand and rock. They did not see the 2 rifles aimed at them from 600 meters. Over 72 hours, the team eliminated 7 observation posts. The Iraqi defensive line lost its early warning capability. When coalition armor rolled forward, the Iraqis were blind. The ghillie suit had moved from jungle to desert without losing its core advantage. Concealment is concealment regardless of terrain. But the next conflict would push the system into the most complex environment yet. Urban ghillie systems represent a radical departure from traditional field designs. Instead of vegetation and burlap, urban variants incorporate rubble-colored fabrics, concrete dust textures, and angular shapes that mimic broken building materials. The goal is identical: defeat the observer's pattern recognition. But the execution requires entirely new materials and positioning techniques. In November 2004, the Second Battle of Fallujah became the most intense urban combat since Hue City. Marine Scout snipers deployed into the city with modified ghillie systems built for concrete and rebar. Sergeant Timothy Kellner operated from a concealed position inside a partially destroyed building. His ghillie incorporated gray and brown fabric strips designed to blend with pulverized concrete. His rifle was wrapped in matching material. From a distance of even 50 meters, his position appeared to be a pile of collapsed wall sections. Over 3 days, Kellner engaged insurgent fighters who were placing improvised explosive devices on the main supply route below his position. His confirmed kills during this period helped secure an entire city block. The insurgents knew a sniper was operating in the area. They searched building by building. They swept the floors where Kellner had positioned himself. His ghillie blended so perfectly with the debris that search teams cleared his building and moved on. He repositioned to a secondary hide on the second floor. Another 36 hours of engagement. The insurgents brought in their own marksmen to hunt him. Kellner identified the counter-sniper team through his scope. He eliminated them at 400 meters before they could establish a firing position. Urban ghillie operations rewrote the manual. The suit could work anywhere, but the next mission would test whether it could work against machines, not just human eyes. Modern thermal imaging and infrared detection systems can identify human body heat through walls, foliage, and darkness. A standard ghillie suit offers no protection against thermal detection. The human body radiates approximately 100 watts of infrared energy. Against a cool background, a person lights up on thermal sensors like a beacon. The next evolution of the ghillie system addressed this existential threat. By 2010, coalition forces in Afghanistan faced a new challenge. The Taliban had acquired handheld thermal imagers from commercial markets. Coalition snipers in traditional ghillies were being detected at ranges their predecessors would have considered safe. The response was the thermal defeating ghillie variant. Multispectral concealment fabric was layered into the suit's construction. These materials blocked infrared radiation by trapping body heat between insulating layers. The metallized film inner layer reflected thermal energy back toward the body instead of radiating it outward. British sniper team from the Royal Marines tested the system during operations in Helmand Province in 2012. They established a hide site 800 meters from a compound suspected of being a Taliban weapons cache. The team lay in position for 28 hours. During the second night, a Taliban patrol swept the area with a thermal imager. The sniper team watched through their own optics as the enemy scanner passed directly over their position. The thermal screen showed nothing. The ambient ground temperature and the snipers registered as identical. At dawn, the team confirmed activity at the compound. Weapons were being loaded onto a vehicle. The engagement was authorized. 2 shots. 2 targets neutralized. The team extracted without detection. The ghillie suit had defeated the one technology that should have made it obsolete. But the next battlefield would introduce an even more dangerous sensor. Unmanned aerial vehicles equipped with electro-optical and infrared cameras now provide persistent overhead surveillance across entire operational areas. The drone can loiter for over 24 hours, scanning every square meter of terrain. For the ghillie suit sniper, this represents the ultimate challenge. The observer is no longer a human on the ground. It is a machine in the sky. In 2017, Ukrainian snipers operating in the Donbas region faced constant drone surveillance from Russian-backed separatist forces. Commercial drones carrying high-resolution cameras flew low-altitude reconnaissance missions over Ukrainian positions multiple times per day. Ukrainian Special Operations developed a counter-drone ghillie variant. The suit incorporated overhead camouflage panels designed to defeat top-down observation. Three-dimensional garnish materials created shadow patterns that mimic natural terrain features when viewed from above. The suit's color palette was calibrated to match the specific soil and vegetation of the operational area using spectral analysis. The Ukrainian sniper team deployed to a position near Avdiivka. Their target was a separatist mortar team that had been shelling civilian areas. The sniper team built their hide over 12 hours. They integrated the ghillie with local terrain features until the position was invisible from every angle, including directly above. A reconnaissance drone passed over the hide site 3 times during the observation period. Each pass was recorded by the sniper team. The drone's camera showed the terrain as unoccupied. On the morning of the second day, the mortar team set up in their regular firing position. The sniper engaged at 600 meters. The mortar team was neutralized. The drone that arrived to investigate the shot found no evidence of the sniper's position. The ghillie system had proven it could defeat aerial surveillance. But the next evolution would push beyond concealment into something approaching technological invisibility. The next-generation ghillie system integrates 4 breakthrough technologies. Adaptive camouflage panels use electrochromic materials that shift color in response to electrical signals, matching surrounding terrain in real time. Thermal signature management layers regulate infrared output to near-zero detection levels. Radar-absorbing fabric woven with carbon nanotube fibers reduces the wearer's radar cross-section. Integrated microsensors provide the sniper with environmental data including wind speed, temperature, humidity, and barometric pressure directly through a heads-up display built into the face veil. In 2023, the United States Army Soldier Enhancement Program began field trials of the integrated visual augmentation system combined with next-generation concealment technology. The goal was a sniper system that could defeat visual, thermal, infrared, radar, and acoustic detection simultaneously. The test scenario at Fort Liberty placed a sniper team wearing the prototype system against a full-spectrum detection array, ground-based thermal cameras, overhead drone surveillance, acoustic sensors calibrated to detect breathing and heartbeat at 200 meters, radar ground-penetrating scans. The sniper team infiltrated to within 300 meters of the detection array. They established a hide and remained in position for 48 hours. The detection array flagged 0 contacts in their sector. On command, the team engaged a target array. The acoustic sensors detected the suppressed rifle report but could not triangulate the source. The thermal cameras detected a brief heat bloom from the muzzle but lost the signature within 2 seconds. The radar scan returned no human-sized contacts. The sniper team extracted on foot. Post-exercise analysis revealed that the detection array had recorded the team's sector as unoccupied for the entire 48-hour period. The prototype system achieved what the designers called full-spectrum concealment. The ghillie suit sniper system has traveled from hand-tied burlap and finished snow to adaptive camouflage panels that fool machines. But the mission remains the same. In the mountains of eastern Afghanistan in 2009, a 2-man sniper team from the 75th Ranger Regiment received orders to eliminate a high-value target. The target was a bomb maker responsible for over 30 coalition casualties. Intelligence placed him in a compound at the bottom of a steep valley. The team infiltrated on foot over 14 kilometers of mountain terrain at night. They wore mountain-variant ghillies incorporating high-altitude scrub grass, rock-colored fabric panels, and altitude-rated thermal insulation. They reached their observation point before dawn. The compound sat 1,100 meters below them across the valley. The shot would be extreme range, downhill in thin mountain air. Ballistic calculations required adjustments for altitude, temperature, angle of decline, and the Coriolis effect at that distance. The team observed for 16 hours. The target appeared at 0630 the following morning. The spotter confirmed identity through a 60-power spotting scope. Wind call. Range confirmation. Elevation adjustment. 1 round. The target dropped at 1,050 meters. The compound erupted. Armed men poured into the courtyard, scanning the surrounding ridgelines with binoculars and rifles. They searched for 3 hours. They found nothing. The sniper team remained in their hide for another 8 hours after the shot. They waited until full darkness. Then they crawled out of their position and walked back the way they came. 14 kilometers. No detection. No pursuit. The ghillie suit did not pull the trigger. The sniper did. But without the suit, the sniper would never have reached the trigger. That is the mission of the ghillie suit sniper system. Make the impossible shot possible by making the shooter impossible to find. From the frozen forests of Finland to the digital battlefields of tomorrow, the ghillie suit sniper system has proven one enduring truth. The most dangerous thing on any battlefield is the threat you cannot see. It does not matter how advanced your sensors become. It does not matter how many drones fill the sky. Somewhere out there, a figure lies perfectly still, wrapped in the terrain itself. Watching. Waiting. Invisible. If this video kept you locked in, hit subscribe and turn on notifications. We cover the most advanced military technology on the planet. Every system. Every mission. Every detail. See you in the next one.